Welcome to the two-phase separator module. This module describes separator types and components, principles of operation, and design procedures. Produced well fluids typically consist of varying amounts of oil, water, gas, and sediment. The first step in processing these fluids is to split them up into their individual components. This generally takes place at some type of separator. A two-phase separator is a device that separates produced well fluid into gas and liquid phases. Separators may be designed in horizontal, vertical, or spherical configurations, each of which has certain areas of application.
Here we see a simplified schematic of a typical horizontal separator. The fluid enters the separator and hits an inlet diverter, causing a sudden change in the fluid's velocity and direction. The initial gross separation of liquid and vapor occurs at this point. The force of gravity causes the heavier liquid droplets to fall out of the gas stream to the bottom of the vessel, where the liquid is collected. This liquid collection section holds the liquid during the appropriate retention time required to let dissolved gas evolve out of the oil and rise to the vapor space. The separated liquid then leaves the vessel through the liquid dump valve, which is regulated by a level controller. The level controller senses changes in liquid level and controls the dump valve accordingly. As the gas flows through this section, small drops of liquid, which were entrained in the gas and not separated by the inlet diverter, are separated out by gravity and fall to the gas-liquid interface. Some of the drops are of such small diameter that they are not easily separated in the gravity settling section. However, before the gas leaves the vessel, it passes through a coalescing section or mist eliminator and cause them to fall into the liquid collection section.
In a vertical separator, fluid enters the vessel through a side inlet. An inlet diverter provides the initial gross separation, then leaves the vessel after passing through a mist extractor. The liquid leaves the vessel through the liquid dump valve, which is regulated by a level controller. Spherical separators typically contain the same elements that are found in vertical separators, and, in fact, are considered a special type of vertical separator. Selection of a separator type is based primarily on gas handling requirements and space availability. Horizontal separators are normally more efficient than vertical separators in handling large gas volumes, but not as efficient at handling solids. They also require more space than vertical separators. Vertical separators, on the other hand, have good solids handling capabilities. They require far less space than horizontal separators and have much better liquid surge capacity, but they are also more difficult to service. Spherical separators are efficient pressure containers, but they have very limited liquid surge capacity and can be difficult to fabricate. For these reasons, they are not commonly used. All separator types have in common certain internal vessel components. Inlet diverters provide the initial gross separation by changing the flow direction as fluid enters the vessel. The deflector baffle, shown here, is one type of commonly used inlet diverter. Another is the cyclone inlet. Wave breakers limit the wave propagation that might otherwise occur in large horizontal vessels. Defoaming plates reduce foaming at the gas-liquid interface, which tends to occur when gas bubbles are liberated from the liquid. A vortex breaker keeps vortexes from developing when the liquid control valve is open, thus preventing gas from being drawn out of the vapor space and re-entrained in the liquid outlet. Mist eliminators coalesce and collect small liquid drops from separated gas before the gas leaves the vessel. Operating problems can occur with any separator configuration, including foaming crude, paraffin buildup, sand accumulation, formation of emulsions, liquid carryover, or gas blow-by. Proper design and sizing of separators is the best way to avoid these problems. Design procedures are based on a thorough understanding of separator operating principles and their relation to such variables as settling of the oil droplets, retention time, and droplet size. The text that accompanies this presentation contains formulas for designing a two-phase separator, together with guidelines and step-by-step procedures for vessel sizing and selection. The text also has tables listing the maximum allowable working pressures for various vessel diameters, along with example exercises and solutions. After viewing this introductory video, please follow the sequence outlined here. First, read the process explanation. Then, review the equipment description. Next, study the design theory and procedure. Finally, work through the design examples.